Hello and welcome to day 9 of Calculus in a Year. Today we're going to be going over some properties of limits. Now, this should be fairly intuitive. The limit as x approaches k of a of x plus the limit as x approaches k of b of x is equal to the limit as x approaches k of a of x plus b of x. So we can just combine these two into one expression. And a similar thing happens with subtraction, except obviously you change this plus sign into a minus sign. Now look at multiplication. The limit as x approaches k of a of x times the limit as x approaches k of b of x is equal to the limit as x approaches k of a of x times b of x. So again, we can combine them into one expression. And then here we have division. So the limit as x approaches k of a of x divided by b of x is equal to the limit as x approaches k of a of x divided by the limit as x approaches k of b of x. So again, you can have these two separate expressions as one. And just want to let you know, in the previous video, we were looking over at all those limits, and I just want you to know that as long as no strange behavior happens near a certain point, like as long as we don't have any sort of discontinuities or any sort of strange behavior like going towards infinity or the like, if we want to find the limit of a function, we can simply just plug in. So for example, the limit as x approaches 3 of 2x squared is equal to 2 times 3 squared. That's 18. So for the most part, as long as a function is continuous and there's no strange behavior as we approach the limit, you can simply just plug in. So just remember that. Now, let's look at an example problem. Find the limit as x approaches 5 of 17x over 2x squared. Now, we can split this up into two different expressions if we want to. We have this, the limit as x approaches 5 of the numerator, 17x, divided by the limit as x approaches 5 of 2x squared. Now, since 17x and 2x squared, they're both continuous and the limits exist for both of those functions, we can simply just plug in. So this is equal to 17 times 5 divided by 2 times 5 squared. And that's equal to 85 over 50, which simplifies to 17 over 10. Now we could have also plugged in straight. We could have just plugged straight in. We could have just plugged in 5 for all the x values, and we would have gotten the same result as you see here. So yeah, just remember that as long as a function has like it's normal at a certain value, like 17 times, for the limit as x approaches 5 of 17x, it's just going to be it's going to be normal. There's not going to be any strange behavior. There's not going to be, the limits won't just go haywire and the function exists, it's continuous there, and x equals 5, it's defined there. That's just something that you should remember. If nothing strange happens, just plug in. If it's continuous, nothing strange happens, just plug in. That's how you can find limits. If we had something like the limit as x approaches 0 of 1 over 2x squared, we'd be dividing by 0, and so that's not allowed, so that's something to look out for. But otherwise, if you have a normal function like, as mentioned before, x approaches 5 of 17x, nothing strange happens over there. It's defined there, and the limits exist, so we can just plug in. So just remember that. normal, just plug in. Continuous lists. Alrighty, and that's really all there is for today. And so, thank you for watching, and I hope to see you back soon.